Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, quick sort on linked list. Okay, so what the problem is saying is we'll be given a linked list. Okay, and we want to perform quick sort on it. So first of all, what is quick sort? Quick sort is one of the sorting algorithms. So what is expected out of it? What is expected out of it is the linked list needs to be sorted. So how the linked list will look like after it is sorted? So it will look like this, right? 8, 9, and then 20. Okay. So quick sort is one of the sorting algorithms, okay, which takes n log n time complexity. Okay. It is one of the optimized sorting algorithms. Okay. Now let's see how quicksort works. Quicksort works on divide and conquer strategy. Okay. So let's imagine this linked list as an array. Okay. 5, 9, 3, 8, 0, 20, and 6. So what we're going to do is in quicksort, we select one of the elements, or in case of linked list, one of the nodes, right? One of the elements as pivot. Okay. So just be with me to understand what I'm saying. Okay. So the pivot can be any element. For example, it can be the first element, it can be the last element, or it can be any random element. Okay. Any random element it can be. Okay. So let's say we select the first element as a pivot. Okay. The first element as a pivot. So let's say we have pivot as what? Pivot as 5. Okay. Now what we're going to do is we will have two pointers here, current and previous, okay, which will be pointing to the same first element. Okay. Now we're going to check what we're going to do. We are going to iterate this array with the current pointer. Okay, with the current pointer. So what we're going to do here, we will check, we'll compare each element with the pivot. Okay. So let's go ahead. So is 5 lesser than 5? No, it is not. So we will increment our current pointer. Okay, so then we'll compare. So we'll update our current pointer to the next this particular, right? We'll move ahead and we'll check if this element is lesser than 5. No, it is not. We'll again uh, like update our current pointer. So now the current pointer is pointing to 3. We'll check. We will compare with the 5, right? With the which is a pivot element. Yes, 3 is lesser than 5. Okay, 3 is lesser than 5. So what we are going to do is we will we will replace we will replace the next of the previous pointer, right? Previous dot next with this current pointer. For example, so previous is pointing here, right? Previous is pointing here. So we will replace. So 9 will come here, 3 will come here. Just be with me. You will understand what I'm trying to, why I'm doing this. Okay. And we will also update our previous pointer here. So previous pointer is now pointing to this. Okay. Previous pointer is now pointing to this. Okay. Now we will proceed ahead. We'll have this current now pointing to this 8. We'll again compare with the pivot element. No, it is not lesser, right? So we will again go ahead. Our current will now point to 0. Now we'll again compare this 0 with 5. Is it lesser? Yes, it is lesser. So in this case, what we're going to do again is our previous is pointing here, right? So what we'll do, the next of previous, which is 9, right? We'll swap the element. We'll swap the element, okay, with the current element, okay? So here, so now this will be 0 and this will be 9. This will be 0 and this will be 9, and we'll also update our previous point. Now previous will point here. Okay, now previous will point here. Okay, then again we'll update, we'll go to the next element, current. Okay, we'll again compare current with pivot. No, it is not lesser. We'll again go ahead, current will point here, and we'll compare 6 with 5. No, it is not lesser, and hence we'll stop here. Okay, at least the first iteration we are going to stop here. So now our arrays look something like this. Okay, till now 5, 3, 0. Okay, 5, 3, 0, 8, 9, 20, and 6. Okay, it looks something like this. Now, our previous pointer is pointing here, right? And then pivot is pointing here. Pivot pointer is pointing here, right? Now, at the end of the iteration, the array looks like this, right? At the end of the first iteration, the array looks like this. Now, when the iteration ends, what we're going to do is we are going to replace, or we are going to swap, sorry, we're going to swap this, the previous with the pivot element. Okay. So our array will look like this: 0, 3, right? 5, 8, 9, 20, and 6. Okay. This our array looks like this. Okay. Our array looks like this. And our pivot is here. Okay. Now, if you see, we had selected pivot as 5. Now at the end of first iteration, this five is positioned at the correct position. At the correct position. If you see, this position for 5 is right, right? So all the elements before 5 will be lesser than 5, and all the elements after 5 will be greater than 5. However, these are not sorted among themselves, but all the elements after 5 will be greater than 5, and 5 will be placed at the right position. Okay, 5 will be placed at the right position. Okay, so whenever you select pivot, after you do all the iteration, okay, pivot element will be placed at the correct position. Then what we want to do is, now we will have recursion calls, okay, for these two sets. Basically, for these two sets, we'll again have recursion call, and we'll select the pivot again. For example, here in this case, we'll select the pivot as 8 now. Okay, after the end of the iteration, again we'll do the same thing whatever we did here, right? We'll do the same thing what we did here. At the end of the iteration, 8 will be rightly placed. Okay, so we are going to do this. We'll follow, like we will call recursion calls, and then until the complete array is sorted. Okay, so as I told you, so we select pivot, we selected pivot here, pivot is placed at the right position. Then what we'll do, we'll take the elements before the pivot, and we'll take the elements after the pivot, and we'll run recursion again, and hence all this process of selecting the pivot and placing the pivot at the right position, it will continue until the complete array is sorted, or the link, or yeah, until the complete array or the linked list is sorted. Okay, so this I showed for the array. Similar thing we are going to follow for the linked list as well. Okay, similar thing we're going to follow for the linked list. Okay, so let's do one thing. Okay, so for example, let's okay, so let's do one thing. Let's erase this. Okay, let's go ahead. Let's go above. So this is our linked list, right? So what we're going to do is, as I told you, right, we are going to select our previous. This is going to be the previous. This is going to be the current, right? This is going to be the current, and pivot also will have a node which will be the starting element, which is 5, node 5. Okay, this is a node 5. Okay, so let's code. I think you'll understand better. First, I'll show the Java code followed by C++. Before going to the code, I'll request you to subscribe to my channel, like the video. Okay, thank you so much. So what we're going to do is, first of all, we are also going to find the tail. Okay, so what will be the tail here? Tail will be this, right? So we want tail, right? So we are going to find the tail as well. So let's find the tail. Node tail equal to find tail. Okay, so this we have node. Now let's quickly write the static node find tail. Okay, and let's say this is head, right? Now what we're going to do, let's have a pointer temp, assign head to temp, and what we're going to do, temp dot next is not equal to null. We'll say is not equal to null. So this will keep on proceeding ahead until temp dot next is not null. When temp dot next is null, that means we have found our tail. So we'll return temp here. So temp, okay, so we'll have tail here. Okay, now we have found the tail. Now what are we going to do? Let's implement a util function, quicksort util, we'll say, which will do the actual okay, so let's write the quicksort util function. So what are we going to pass here? Node, which is head and tail, right? Okay. Now let's write a util function here. So what are we going to write? Static void quicksort util. Node, let's say head, and node tail. Okay. Okay. So this node is nothing but head only. Now first let's write the base condition. If head equal to null, or head equal to tail, right? Which is wherein we have head equal to tail, which also means there's only one node. Okay, there's only one node. So let's return. This would be the base condition. Return from here. No need to sort. It will be sorted basically. Okay. Now what we're going to do is we are going to write the partition algorithm. So partition algorithm in the sense, let's see what how does that partition function look like? So we'll have a pivot element, let's say, and partition. Let's pass head and tail. Okay. Now let's implement the partition function. Okay. And also let's see how this partition function will work. Okay. Let me also zoom this. Let me reset this so that we're clear to you. Okay. So yeah. So static node partition, let's say, node head and node tail. Okay. So what we're going to do here? Okay. So as I told, first we'll take node previous equal to head, node current equal to head, node pivot also equal to head. That is, we are going to take the first element as a, or first node as a pivot. Okay. And we are going to run a while loop. Current, while current is not equal to tail dot next. So why tail dot next? Because we also want to consider tail. Okay. In this process, right, of partitioning, we also want to consider tail. If we say current is not equal to tail, so we will skip. In that case, we'll skip tail. So we want to consider tail, right? That is why we are saying tail dot next. Okay, tail dot next. Okay. Now what we are doing here is, for example, let's say, so as I told you, right? So previous current, both will be pointing to the head, and pivot also is pointing to the pivot will be the first element, right? Or first node. Okay. So now we are going to check here if current dot data, if current dot data is less than pivot dot data, right? So what we're going to do, for example, here we're going to, for example, here is a current pointer, right? Current pointer is here, let's say, right? These nodes, their values are not lesser than pivot, right? So for example, here we got a value which is lesser than pivot. So in this case, what you want to do? So as I told you, we want to, now previous is here, right? Previous is here. We want to swap the value of the current with the previous dot next value. Okay. I have already explained this. So in this case, what we're going to do? So simply, whenever we find a value which is lesser than pivot, so we will update previous pointer. Let's say previous will point here. Okay. And then we will swap the values. Okay. And then we'll swap the values. Okay. Let's see how it looks like. So first of all, previous equal to previous dot next, we'll say dot next. Okay. And let's swap the values. Temp previous dot data equal to current dot data, right? And current dot data equal to temp. That's what we are saying, right? So now how it will look like? So this will be, so this will look like what? So this 9, this node will now have value as 3, and this will have value as 9. Okay. And then what we're going to do, we'll proceed ahead, right? We'll update a current pointer. We'll move a current pointer to the next, right? So current equal to current dot next, we'll say. Okay. So again, when we come here, right? When we, for example, when we come to this node, right? Current is here, right? So what we're going to do, we'll again update our previous pointer. So previous is here. So we'll update our previous pointer. Let's say previous is pointing here now, right? And then we will swap the values again. So with the current, so 0 will go here and 9 will come here. Okay. So 9 and 0 here, right? So that's what we are doing here. That's what is a process we are doing here, right? So once this is done, once this iteration is completed, then what we want to do is, so now our previous. So how will this look like, right? This linked list will look like something like this: 5, 3, then 0, 8, 9, 20, and 6. Okay. And the previous is pointing here, right? Previous is pointing here. It will point here because there were no elements ahead which were, or node ahead which had lesser value than pivot. Okay. So previous will point here, pivot is pointing here. Now at the end of the iteration, we are going to swap the values of pivot and previous. I have already explained this. So we're going to do that. Okay. So again, let's copy this. Let's not write implement again. Let's copy this. Okay. So here is a code. So instead of current, we'll only need to have pivot, right? Pivot dot data. Pivot dot data. So now what we're doing here is, so this will have 0 and this will have 5. Now, if you see, How our linked list looks like? How our linked list looks like now? 0, 3, 5, 8, 9, 20, and 6. Okay. So now our previous is pointing here, right? Previous is pointing here. So this previous is going to be the pivot now. After swapping, this previous is the pivot now. Okay. So what we're going to do? We want to return our pivot, right? For the final pivot. So previous will point to the pivot. Okay. So here if you see all the elements before 5, they are lesser than 5. And all the elements after 5, they are greater than 5. Okay. So this pivot is rightly placed. Okay. It's sorted now. It's sorted at the right position. Okay. Now what we're going to do? We are again going to run the partition or quicksort algorithm, right? On the remaining sets, we'll say, on the remaining subsets. Okay. Okay. So how are we going to do that? So this partition is done here. So what are we going to say here? So we are going to now, first of all, we'll again call recursively this quicksort util. Okay. For head and pivot. Okay. And okay. And what if pivot is not null? And pivot dot next is not null. Then in that case, we are going to call the second part, right? Second part, which would be pivot dot next, right? Pivot dot next and till tail, we'll say till tail, right? So what we are doing here is we are calling the quick sort on the remaining sets, right? On the remaining subsets. This part, right? This particular part is taken care by what? Is taken care by this recursive call. And this part, pivot dot next, right? To tail, till tail. It is taking care for this particular set. So recursively, we will continue doing this until this base condition is executed. Until this base condition is executed. Okay. So finally, once this is executed, our linked list will be sorted. Okay. So final step is we want to do what? Just return node. This node will contain the sorted head. Okay. Let me compile this now. I hope you have got the solution or intuition. Let's quickly compile this. Okay. This is sorted. Let's submit it. Okay. I hope you have got the solution. Please subscribe to my channel. Like the video. It will really motivate me. Okay. The test keys are being processed. So I'll also attach the code. Okay. Time limit got exceeded. Why? Let me submit again. I have observed some issues with Java compiler. Yeah, now see, the test keys are processed. Okay, thanks for watching. Please subscribe to my channel. Let's quickly see the C++ code as well. Okay, so here's the C++ code. Let's start with this one, quick sort, right? So here we are finding the tail. The tail function is here. Okay, the tail function is here. Okay, I'll attach the code. You'll understand. You can go through. I have already explained the intuition. Okay, then once we have found the tail, we are calling the quicksort util function, passing head and tail here. Here we are having the base condition. I have already explained this. Then we are calling the partition algorithm. Okay. Okay. So here is a partition function here. So we are taking the first element as a pivot. Then we are assigning head to previous and current pointers. Okay. Here we are running the current. We are iterating till the tail pointer. Here we are checking if the current data, if it is lesser than pivot data, then swap the elements. Okay. So here it is. And then finally swap the previous with the pivot and return previous node. Okay, which will be the pivot. Okay. And once we found the pivot here, then the run the quicksort again, or the partition algorithm or quicksort again on the elements, on the nodes before the pivot and on the nodes after the pivot. Okay. So finally we'll have our linked list sorted, and finally we'll return the head of the sorted linked list. Okay. So this is the intuition. This is the code. I'll also attach the code in the comment section. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.